Last time on SOLIDWORKS at Home, Sean set out on a journey to create the perfect sparring robot. After some tireless research, he settled for putting arms on a punching bag. He created each existing part one by one and then set about designing a brand new component. He succeeded at this, but assembling the parts together could prove an even greater challenge.
Hey, it's Sean Marsden, Application Engineer with Hawkridge Systems, and welcome to Part 2 of SOLIDWORKS SOLIDWORKS at Home. In this video, I'm going to be creating the assembly. So hopefully you caught my previous video where I built up all of the individual parts. If not, maybe jump back to that one. In this video, we're going to be bringing all the parts together, and we're going to cover creating mates to put them together, grab Toolbox components for hardware. We're going to look at evaluation tools such as interference detection and collision detection, and we'll also look at how to edit components, so changing dimensions as well as maybe actually adding in new features. Alright, the first thing we're going to have to do is obviously start an assembly template. So I'll grab one of those, and then we're going to start inserting parts. So I pinned that in place so I can get multiple parts in there, and I like using that graphics preview if the files aren't too large and complex. Your first component, generally you want to somehow lock it to the assembly origin by either clicking little blue origin or the green checkmark in begin assembly. Otherwise, everything else can just kind of float in space. Fixed components important just for the mates to be able to have something to solve around. Alright, after that, I'm going to start making copies. So if you hold down the control key, you can just click and drag on a component and it'll just make a quick copy for you. So that's pretty easy. The control key can also be used to create mates. So this is my preferred mate shortcut. So hold down the control key, click on the faces or entities you want to mate, and then let go of the control key and you'll see a little mate toolbar pop up. Don't forget while you're mating that you have a lot of flexibility on what you choose to mate between. So I just did reference planes, but you can do other reference geometry, sketches, all sorts of stuff. I usually like to start with concentric mates. It helps to really lock components down. And then here, because there's actually a little cone at the top of there, I'm going to try using an edge-to-edge coincident mate. You do have to be careful with these because they have to be exactly the same diameter for it to work. After that, I'm going to switch some configurations, so I can do that by just clicking on a component and using the drop down there. Don't forget to hit one of the green check marks though. I'm seeing that these parts aren't matching up, and so I need to just try flipping the orientation of this bamboo rod, which means I need to find that last concentric mate I made. And one of my favorite ways to just kind of work with mates in an assembly is with breadcrumbs. You can see popping up here. So if I select a component and then I hit the D key, it'll bring all the information from the feature tree over to my mouse, and then I can do things like right click and flip mate alignment. The diameters still don't match up perfectly, so I'm going to quickly, and definitely not in any kind of super sped up way, go and make a new configuration and then swap it out. So here I'm going to use breadcrumbs again to be able to go and edit a mate that I just added in, because I realized maybe I should do this as a distance mate instead of a coincident. If you don't have breadcrumbs available, you've never seen them, you might need to activate them in system options. So this is a pretty common problem for people when they don't have components that are fully mated. My pool noodle is in the correct location, but it can still spin, which makes it really hard to just rotate the entire assembly. So the easiest thing to do here is just lock the rotation of the concentric mate. So in a second here, I'm going to be dealing with the washer that's floating up there. In the first video, I created a surface body out of a mesh file. And this is just there as a placeholder. You do need to be careful when you're using surface bodies like this because they're not going to show up in interference detection or mask properties. Maybe not so much careful as you need to practice mindfulness, as we all do in these trying times. Now that I've had my moment of guru-ness, I think I'll shift back to something I actually know. Let's take a look at the Toolbox components. The Toolbox is part of SOLIDWORKS Professional. That's that mid-tier version of SOLIDWORKS, and it's just this huge hardware library. So it has a ton of different standards. I think I'm pulling out of like ANSI inch right now, maybe ANSI metric for this bearing, but it basically has a huge database of different sizes. So I can go and just search for the component that I'm looking for, and it can auto size based off of like the shaft that I'm bringing it over to. There's also mate references built into them, so they can kind of pop into place and create mates that would put them, you know, in this case on shafts or line up with holes or flush to another component. So it's a really handy tool. There's a lot of stuff built into SOLIDWORKS that builds off of the Toolbox to make it even more convenient. There's a lot more that goes into the Toolbox, so maybe I'll put a video in the description if you want to get more details on that. Oh yeah, I just went and looked. We totally have a Toolbox video, and it's by none other than my boy, Ronnie Godoy. Alright, so for the last mate, I'm going to use a with mate, which basically centers components. So I'll just select these four faces, and then it'll make sure my threaded rod is nice and centered on the stack of hardware. And it helps me check that's the right length, so it's a real win-win, folks. Okay, a little detour here. My cosmetic threads are not showing up on that threaded rod, so I'm just going to change it in my annotation details here.
Alright, now it's time to clean house, brother.
Alright, so cleaning up your feature tree in assembly is really nice because it gets really large, right? So I like to put hardware into a hardware folder. I'm just naming that. You can drag things in and out of these folders, group like items or things in similar areas of the assembly. Then a lot of things are done in the tree display options. So you can do this do not show configuration / display state names if only one exists. That really gets rid of a lot of that extra default display state stuff in there. And then group component instances is nice. So if you have exactly the same components, like my pool noodles, it'll put them as like one item. Before I forget, the little arrow next to this eyeball, this controls what you can see in your graphics area. So you can I can turn off the origins here, or if you want to see plain sketches, that kind of stuff. Time to get into interference detection. So a very important evaluation tool. So a couple things I like to set while I'm in here. One, creating a fasteners folder. So if you're using the Toolbox, then it's going to clump all those things into a folder just for interference with that. I'll talk about that in a minute. And I also like this hidden option. It hides things that aren't part of the interferences that we're checking with. So I'm going to hit calculate to check for the whole assembly. I have two non-fastener interferences. These were expected. It was the pool noodle press fit. For those ones I was expecting, I'll go ahead and just hit ignore. That way it's just going to be ignored for future checks. Though you also can see that I have show ignored interferences turned on. That way I see them in this grayed out view instead of just having them disappear. So now I do want to double check my fasteners, because even though usually you can expect anything that should have threads on it is going to interfere, that's expected. This is not expected, so that's supposed to fit based on a dimension that I created in the part file. I can see I have a tiny interference there, so I guess that dimension's wrong. And how did that little guy get in there? Oh man, okay, so I just accidentally inserted an extra tiny washer at some point and didn't notice it. So yeah, we're gonna have to take care of those guys. Okay, quick pause here. Looking back on this part of the video, I'm realizing now that I probably didn't need to go through all of this effort to fix such a tiny interference, especially since it's all just on a threaded rod and it probably would have fit just fine anyway. But at the very least now you'll just kind of see the process that I went through to fix this, so enjoy! Okay, so here's where things aren't quite fitting. So So first I just want to check what the mates are here. So maybe I just did mating incorrectly. That's pretty common. And no, that's what I expected. So it's mated to that face. It should just fit because I modeled in the size of this. So I'm checking the dimensions right now, doing quick measurements. I just selected those two interfaces and I looked down at my bottom bar on SOLIDWORKS and it says 0.063. And then I'm going to isolate this washer. So the isolate tool, right click on a component or two, hit isolate, it's going to hide everything else. That's 0.065. So that's not okay. So the washer itself is actually too big. So maybe I chose the wrong washer. So let me go ahead and change the toolbox components. So right click, edit toolbox, and I'm just going to see. So 5/16. So I said that was supposed to be 1.6 millimeters. So I got that from measuring a washer at my place. So maybe I'm just using metric washers. So I'm just going to try swapping this out for a totally different washer. And if I go and try the 5/16, roughly 8 millimeters, and yeah, that thickness is totally off. It's definitely not 1.6. So I think I do have an anti-inch washer in real life. I just must have measured it wrong and thought it was millimeters when it really was just a 5/16 washer. So we're gonna just go ahead and leave the toolbox components alone, and I'm gonna fix the dimension on the part instead. Alright, so I'm just gonna go and double click on a face of this part so I can update some dimensions, and double click on the dimension, and so this was controlled by an equation, and apparently it does not want me to edit this outside of edit component mode. So I'm going to select on this component and then say edit part. This will get me into like a special edit just this part mode, and I'm just going to completely wipe out this equation. I'm just going to set it to the dimension that I want. So 0.065 and hit rebuild. After that I can hit the edit component button again to get out of here, but I did configure these parts, so I'm pretty suspicious on making sure that this dimension actually, and yep, there's still a little red sigma at the dimension saying that this is still equation based. So what I'm going to do is just go into edit component mode again, and I'm going to just wipe out the equation. I thought I was being so clever with the equation in the last video, and now here it comes to bite me in the tuchus. So I'll wipe out the equation, and then I'm going to use the modify configurations table that I also showed in the previous video, just to make sure that dimension is the same across both my configurations. After that's done, one more interference check just for good measure, and we should see that we just need to take care of that weird errant washer that's floating in my parts. Ooh, one extra little tip here for big assembly trees. Shift C, that's the shift button with the C key, will collapse your whole tree. Alright, well those were some trying times, but we finally get to move on to collision detection. This tool is hidden underneath move components. Select collision detection under options, and then since this can be a resource intensive tool, I like to use the option these components and dragged part only, which is basically just going to check for collision between specific components. Clearance is a little tight here between these components, so I'm just going to go and update a dimension. So same thing as before, double clicking to show dimensions, double clicking to modify them, and hit the rebuild button to see that change immediately. If I want to get more range of motion, I can try going back into edit component mode or edit part mode and adding in like a completely new feature. So anything you do while you're in this mode only affects the part that you're currently editing. So in this case, I'm just going to be using a chamfer, but I could be doing like a cut that would only affect this part, or I could be using other components in the assembly as more than just visual reference. I could add in external references as well. Though I would add in that if you want to create external references between components in an assembly, keep it simple and make sure you can manage it and remember how all those relationships were built and how they update. So a little more management with configurations here. Default configuration settings are there to kind of keep them different. So the chamfer I added into one has been suppressed in the other, and I just need to go and unsuppress it. The last thing I wanted to show in this video was how do you set up a dimension so I can actually see what the angle between these are at any given position. So you can do that with the Smart Dimension tool. You just want to choose the reference dimension option, and then I'm going to use reference planes. That's an easy option. And then now I can continue using collision detection if I want to and see what the whole range of motion is. So this simple assembly is done at this point. I did create another part that it's the shoulder, if you will, that attaches this whole thing to the punching bag, but that's really a topic for another video. I'll show you in that one how I use the topology study in simulation to design that part. I also am omitting where I went and just threw a bunch of fillets all over the little part that we've been building, just so it would print a little stronger. And I'll tell you, I actually had some failed parts earlier because I forgot. I left a bunch of sharp corners on there, but I'll show you all three of these parts printing right now. Alright, so we're done here. I just want to thank everyone that's made it to the end of this long video. This is kind of a different format for me, so please let me know in the comments how you like it, if you want more videos like this one. And I work on a lot of projects at home, and I'd love to share them all with you folks out there. Thanks for watching, and we'll see you next time.